is simple and clear. It should be fairly understood by all of you. It will build up on last time, and even if you didn't attend last time's lecture, what we'll do will help you. Occasionally, I will go back to show you certain things, but it's based on your questioning that helps me to move on. All right. So, what is association rule mining? Association rule mining basically helps you to answer a question like this. Which items are frequently bought together at the Accra Mall? But Accra Mall is big, so let's go to the ShopRite itself. When you enter ShopRite, which items are frequently bought together? And I've actually put papers that have been published on some of these things so that you know that this can be an essay topic or a dissertation. Another question could be, so this question alone could be, if a customer buys item like milk, what other items are they likely to buy? Association rule mining will help you address this. Which product combination can guide you as the owner of the shop to shelf place? So if you are going to do placement, you are going to put things on the shelves, or if you are going to park some cars in a garage for selling, which cars are you supposed to park them closer to each other to the extent that if a person looks at this car and he doesn't probably like, he's more likely to take this other car? Are you guys with me?
Yes, Doc.
Yes, sir.
If you want to do promotion for your product, let's say MTN wants to do promotion. Should I do the promotion on the text message, on the data, or on calls? Which one do you think people will like them to do promotion on?
Data, sir.
Exactly. Data. It cuts across. Everybody will go for data. So association rule mining helps you to know what combination of products to do for promotions, for bundling, even for recommendation systems. For example, Netflix gives you a comedy. You watched it to the end, and they know you watched the movie to the end. You didn't just look at the trailer, you watched it to the end. And now they see that because you watched that comedy to the end, if they are recommending the next movie for you, will they give you horror, action, comedy, or drama? Which one will I give you? Grace.
They will give you another comedy
Why?
because they can tell that you watched it to the end, so it's assumed that you enjoyed it.
That is association rule mining principle. And that was what we looked at. So we are looking at how are they associated? These things, how are they associated? Now, there is a process to develop this association rule mining. And last time we looked at item sets. And when you look at item set, there are several things you can examine around an item set. We looked at, in fact, let me just take you back a little bit. We looked at all of this, but there was one particular thing that we said, which I just want to show you. The metrics that are used to measure the strength of that association. If there is an association between bread, milk, sugar, but there is not much association between sugar and waakye, How would you know that there is no match? What is a quantification, the numerical equivalent? That will tell you that there is no match association. What is a value? That tells you that. We looked at support, confidence, leverage, conviction. We looked at all of them. Now, we're going to do a practical thing to showcase how all of these play. And to do that, I want you to remember some few things. We have to formalize a statement of the problem. And to do that, you need to find all items whose support is greater than the or equal to the minimum threshold. Now, the minimum threshold is given as the MIS support, the minimum support. Now, we've looked at support last week. So we want to find which items frequently come together in the transactions. If a customer often buys bread and butter together, that pair is a frequent item set. And what has happened is that over the years, researchers and academics have developed different algorithms to solve this problem more efficiently. That is, to be able to handle items that come together, that frequent item set, how to be able to actually know that, oh, this one and this one are frequent item set. And there have been methods that have been used to establish that. The first one is a priori. That's a foundation algorithm. And in fact, that's the only one we shall do. And it's a popular and it's common and still powerful. We'll use that to establish that association rule. There is also the Agrawal and Minesky Swami one, AIS. There is a set-oriented mining, SETM. There is a priori TID, a variation of the a priori. And then the one that combines the best of both worlds, which is a hybrid. All of these are designed to compare how powerful or the efficiency of the association. And normally when you have done all of this, you can now use some analysis to compare which of these algorithms is the best. But a priori has been consistently to be the key. So let's look at the a priori algorithm, and then we'll look at a practical demonstration. Please open your a priori Jupyter Notebook 1 and 2. So the algorithm is probably the best known algorithm for association rule mining. A priori algorithm. Depending on where you were born, how you pronounce it is different. You can say a priori or a priori. Is commonly used to detect relationships among items in a very large transactional databases, especially big one, Walmart, Sainsbury, Tesco, ShopRite, big supermarkets. So for market analysis, especially not just entire market analysis, but market basket analysis, that trailer that you take and that basket, the items that are in there. Now, why is this powerful? It's powerful because I just told you that if you know that a customer is going to buy this, you make sure that you are grouping them together. You don't say that go and buy toothpaste here and then walk, 10 minutes in the big supermarket to go and buy a toothbrush there. They are together. So what the algorithm does is two things. One, it will find the frequent item set among the large data set. And when we say a frequent item set, it is also known as, yes, Angela.
Okay, so please, with the inquiry, we have
Increase your voice.
Please, Bishop. Hello, can you please hear me?
I can't hear you.
Hello. Hello.
Mm-hmm.
So please, I'm asking that with the April, we have two. You sent two, so which of them should we load?
We have two.
Yeah, you sent two to the group.
And I said both of them. We have a priority 1, a priority 2. Check it. One is just
Okay.
APRI, the other one is APRI 2. There are two documents. We are working on both.
Okay.
A frequent item set is an item set whose support, and then this is a repetition, the support is greater than or equal to the minimum support. We'll define what the minimum support is. And then, by the way, for your information, we've looked at support. And I know you remember support. So here's the APRI principle. It simply says that if an item set, that is, look at your basket of goods, if the item set is frequent, then all of its subset must also be frequent. So the key point in the APRI is to find the frequent item set. Then after that, you will generate an association rule for it. So once you find a frequent set, APRI will generate an association rule. The association rule will indicate that X maps to Y. That is, it will find which items occur frequently, and then it will use those frequent combinations to generate the rule and say that if a person buys butter, buys bread, he's also going to buy butter. So X is the bread, and then the Y is the butter. So each rule is created, and you will have to find the confidence of the rule. And last time we looked at how to manually calculate confidence. When you have a rule whose confidence is above the minimum confidence, then you keep that particular, rule. You keep that particular association. So we're going to go to these are the details of the steps, but I will look at it also when we go to the Jupyter Notebook. So let's go to the Jupyter Notebook and see how all of this pan out. So I have on my screen here, I want to just move this one so that this. Okay. Can you see my screen now?
Yes, Doc.
Yes, Doc.
So just a recapitulation, just a repetition of what I've said so far. Association rule helps you to address some questions like this. Which items are frequently bought together? If a customer buys bread, what other items are they likely to buy? It's not guesswork. Oh, this is not a guesswork like tell me, then you're guessing. No. Association, because you're talking about large items in a supermarket. Sometimes we are talking about 5,000 different items. You need to be able to, in fact, Rapid Miner will even draw and map out that this one and this one all move together. This one, and then it will tell you the percentage of them moving together. But the question is, why are we using APRI? Because we are using APRI to find the frequent item set and then to generate the rules for those item sets. So in this particular database I'm about to show you, which you have seen it also, APRI will identify the common shopping patterns and it will reveal the hidden association between them. Now, I tried the data and I realized that it wasn't running. So to be able to do this first time, you need to pip install something known as machine learning extension, MLX. Okay, you need to pip install it. And so I have the command. I've also given you the instruction. Okay, so you can run this command if you haven't run it. Run this command so that your environment will accept it. It will take some time and you see so many things will populate. So run this command and confirm that a lot of things populated, and therefore at the bottom you see that the MLX extend, which is the machine learning extension, has been installed. I mean, for you to know that yours is already working, you can run this command, the import pandas from ML extend for the import for the transaction encoder, and then for the APRI. Okay, run this command to be sure. If it doesn't work, it means that you've not installed it. So somebody should run and tell me that it worked or it didn't work. Any of you can tell me.
Doc, it worked.
So yours worked. Grace, what about
Mine
yours?
also worked. Mine also worked.
After the pip install, before even the pip install.
No, after the pip install,
Of
it
course,
showed
of
the
course.
long thing, and then
After the
after
pip install,
that,
it should work. Somewhat.
Doc, please, mine also work.
Esther.
For my access was denied.
Okay, that is before the pip install.
Yes, please. And after too.
After the pip install, you've been denied access.
Yeah. It didn't work. They said no model named ML extent.
Okay, I'm going to allow you to share your screen. I need to know what the problem is. Share your screen. Try to share your screen and let me see.
Okay, sir.
If you're not able to share, let me know. Okay. Perfect. Okay, so yours is showing now. So go up, and let me see. Okay. Are you online?
Yes, sir.
Okay. So if you're online, run it again and let me see.
Still the same.
Yeah, I see that. It's quite strange. What will happen? Just a second. I mean, what could deny you like that? Let me double check something. Okay, so you are supposed to run this thing on the local Python environment. I'm sure you are using the local Python environment. In your case, you are using a Jupyter notebook.
Yeah.
Okay. Maybe you've not done the upgrade. So after the pip install, after the END, do two minuses and then type upgrade. Okay. Run that and let me see. You got the same thing.
Yes, please.
I can't see the app there. All right. So remove the upgrade that you did. You're going to restart. I'm sure your Anaconda is opened.
Yes, it's opened.
Okay. So restart your Jupyter notebook. Close your Jupyter notebook.
Okay.
And then wait. Click on the, okay, no, you've already opened it. So open it again. Just enter to open it again. Yeah, you restart and let's see.
Okay. The whole
Yeah, the same command again.
okay.
Click inside and run it.
Okay. That's still denied.
It still says 8 minutes ago.
Okay, so then let me just.
Yeah, maybe you have to terminate it instead of just closing. Terminate it because it's still running in the background. You don't have to terminate it because you see at the top here, it say running.
Okay, so how do I don't know about that.
Open it and kill the kernel.
Mm,
So there are two possibilities. You can restart the kernel. Click on restart the kernel. Yes.
Then I open again. Yeah.
Okay, run it and let me see. Maybe we should even shut it down.
Okay. No, it didn't work still.
Yeah, don't bother about running the second one. It's the first one we are interested in.
Okay.
Yeah, it's a pip install that we are interested in. Which, I mean, the only possibility sometimes is to you kill the kernel, it didn't work. You do is to reopen Anaconda, like you close the entire browser and then reopen Anaconda fresh. That's one. And then, or after that, if that doesn't work, you just restart your computer.
Okay.
Yeah.
All right.
So do that whilst we proceed. You come and join us later.
Okay, sir.
All right, guys, let's move on. So most of you have run the import function, okay? And when you run the import function, it will not tell you that anything is loaded, so everything is fine. Now, the name of the data is here. So I have some few questions. I want you to look at the data set, okay? This is the transaction data set that you see here. I want you to look at the data set very carefully and tell me how many transactions are in this data set. Just with your eye, because it's not many. Normally, in a normal situation, it's so many. But this one, when you look at it, how many transactions are in the data set? Anybody can raise a hand and tell me. Actually, just to give you a clue, for you to know the number of transactions in the data set, it is that square bracket per items. That's what I mean. Somewhat.
Doc, please, yeah, 5 transactions.
There are 5 transactions. Do you all understand? Okay. Do you all get why he got that 5 transactions?
Yes, Doc.
In this case, he counted it. Ordinarily, you won't count, but in this very example case, he counted it. Hey, just a second. Okay. I was going to show you just a code for you to see the number of transactions. No. Just a second. So that, I mean, if you have a very large data set and you want to know the number of transactions, you're not going to count like this. Okay, so this is it. You type lens into bracket data set. I mean, you can do it, and then we see. So here, okay, you can just enter a cell, click and enter a cell and type lens into bracket data set, because that was the name of the data set you have here. So you tell it to tell you the lens and then run it. Okay, looks like I've not loaded my. All right. Let me see. Okay, first, okay, the best is to use the number of transactions and define it. So you can say number of transactions equal to length. And in fact, that one should still work anyway. Underscore.
Doc, please, I worked.
Yours worked. Supposed
Yes,
to.
please. Your own, you wrote lens.
I made a mistake. It's a typo. So just length, exactly. And you get the number of transactions to be 5. Okay. So if you have 1 million transactions, and this can happen in a year for big companies, you can just use lens, or len, sorry, not lens, len. Data set, the name of the data set. If the name of the data set is data set, you use data set, right? So DF, use DF. And then that will tell you the number of transactions. But for this one, I wanted you to use your eye first before I tell you this. Okay. Now, next one is list all the unique items in the data set. So that's the next question we are being asked to do. If it was an exam, that's how it is. You'll be asked to list all the unique items in the data set, identify a one item set, a one item set, a 1 2 item set, a 1 3 item set, a 1 4 item set, like that. In other words, which item set are 1 1 1 1, which item set are 2 2 2 2, and 3, and so like that. Okay. So now look at the data here. What does this mean? First of all, each inner list, I'm going to pick a couple of inner lists. So what I've just highlighted here is an inner list before the comma. That tells you one transaction. Okay. The next inner list starts from which item? The next inner list starts from which item? I just want to be sure that you're following me.
Bob deal.
Deal.
And the last inner list ends with which item?
X.
X.
Very good.
X.
So each element is an item. Okay, and in this case, the item is a word. Okay, and that word is an item that was purchased together with the others. So, for example, I've given an example here: milk, onion, nutmeg, kidney beans, eggs, yogurt. This means that one customer bought all these items together. That's what it means. Okay, and then another customer bought the first one you mentioned, and then the second one. There are 5 different, transactions. Now, you will see that some of the items are duplicates. For example, if you take onion is in the first, transaction. Onion is in the second transaction. Onion is not in the third transaction. Onion is not in the fourth, but it's in the last transaction. Okay. So onion appears twice. Sorry. If you take the last transaction, rather, onion appears twice there. So they are duplicates. But when they are duplicates, it doesn't affect the calculation of the support, the confidence, the list, the leverage, and the consistency. It doesn't affect any of them. So take note of the fact that if they are duplicates, what do I do? Normally it happens. A person can go and buy, the person can go and buy ginger. Then after a while, he goes and says, Charlie, I need 2 more ginger because I'll be doing another one and another one. So he goes to buy another ginger, the same thing again. And then even sometimes the third one. But those are the calculations. Okay, so what the a priori function is going to do is that it's going to check this entire database that we have. And then it will use a one-hot encoded pandas. Okay, if you look at them, everything you're seeing here is in English, is in the text. But then the method doesn't allow for texting. Okay, a priori cannot work with text directly. It needs the data to be 0 or 1, binary. Binary means the 10 is there, the 10 is not there, the 10 is there, the 10 is not there. Presence, absence, presence, absence, presence, absence. That means 0 or 1, yes or no, true or false, like that. Okay, so given that data set, we can transform the entire data set into the right format so that a priori function can work on that. And to do that transformation, you use something in Jupyter Notebook, a library known as transaction encoder. And so we're going to run this transaction encoder. So we'll call it TE. Okay. we expect that TE would define the transaction encoder for us. And then the TERE will fit the data set and transform it for us. And then finally, the transformation, once it's done, we want the new data set, okay, indicating the presence or absence, the presence or absence, the presence or absence, and then we'll show the entire data set here. So this is the result. Let's run it here, and this is the result. So you can see that the 0 here is referring to what? If you look at this 0, it's referring to what? You can tell me. The 0 here stands for what? Grace.
The row ID, the number or ID.
The what?
The row number or ID.
The row number. Yeah, but what does it represent in what we are discussing here? Samuel.
Doc, it represents the first transaction.
Exactly. It represents the first transaction. So when you have false here for some of them and true here for some of them, what does it mean? Anyway, I've given you all the answers. James.
Yeah, so true in the list means that the item is bought. False means the item is not bought.
You said true means what?
True means that the item is in the transaction, and false means that item is not in the transaction.
All right, okay. So by looking at the information that you have here, you'll be able to tell that the first item that was in the transaction was egg. Okay. The second item was kidney beans, then milk, then nutmeg, and finally yogurt. That is why they are true. Of course, if you go here, you see all of them there because this is a small data set. But remember, in real life, it's not a small data set. If you go to Netflix, the amount of movies people are watching per day, who can tell me? Do you know? Do you know
No.
how many movies people are watching per day in Netflix? You'll be shocked. Let me see any of you. But the thing is that you will not normally get that. If you check online, they won't actually do that because that is a kind of data privacy. But then on average, a Netflix user will watch about 60 films per year. On average, 60 movies. And that works an average of one movie every 6 days. It's possible that some people are watching different movies or some people are watching the same movies. But the key point is that if it is in a transaction, which movies will be watched today? You'll be able to use that. Okay. And then you know the transactions. So that is the results that you get. You get the false here is simply 0, and the true here is simply 1. Okay. So sometimes you can convert it into 1s or convert it into 0. Okay. Now we are going to return the items with at least 60% support. Okay. And then we will use a minimum support to be 0.6. Now pay attention here. We are going to now proceed to return the items with at least 60% support. Now, why am I using 60% support? How many transactions do we have? 5. Okay. And therefore, 0.6 times 5 will give you 3, which means that the minimum support that we want being 60% means that an item set must appear at least 3 times to be considered frequent. So we are not just considering any time, anything frequent for any means. For example, you appear twice, then you start blowing your trumpet and saying that, oh, I'm a frequent, item. People buy me a lot. Milk will say that people buy me a lot. When only 2 people bought you. Okay. So because one of the definition of support, okay, if you can go back to your note, if you check back your note, okay, and you will see the definition of support. Let me just show you. It's just to remind you. It's not to say that you don't know. It's just a way to. How do you even show the slides? Yeah. So this is support. Support is frequency of the item relative to the total. Okay. So we want to actually calculate support, but we want to give a minimum value to that. For you to be seen as frequent, then we are saying that you must have appeared 3 times. But how do you define you must have appeared 3 times? Okay, first you must know the total. Okay, you must know the total. And once you know the total, then you can now be able to what? Find the 60%. Because what is the total items that we have? The total item is 5. What is 3 divided by 5? Is 60. Are you guys with me? Okay, so, but if you want to say that I want the minimum support to be 2 out of the 5, then you can now use the number 2 divided by 5 to calculate, which is 40%. Okay, but for this, we just don't want anybody to just get up and say I'm frequent. So we selected a minimum support to be 60%. Okay, so we are going to now run the a priori. Okay, we told you that the a priori is a way for you to be able to determine the frequency. The a priori is one of the methods that we are using to discover the relationship among these transactions. And the first thing you want to do is to find the frequent item set. And the frequent item set will require you to use the support, because the support is the calculation of that. And then after that, you generate the association rule. So that is why we are doing this. A priori principle is very simple. It says that if an item is frequent, then all of its support must also be frequent. So first, we need to determine the frequency. And that is why we have used the minimum support. So what we are actually telling the system to do is that look into the entire DF, the data set. Given that the minimum support, tell me those that are frequent, given this minimum support. So you run this. I want you to run that. And you will notice that by default, the column indices of the items, okay, is what a priori returns. So a priori is giving you the column indices here. So for the first item, so these are item O, not transactions. So transactions are 5, and the items are 10, 11. So the first item, okay, the support value is 0.8. And the item set in there, these 3 different item sets. Now, the numbers are a little bit difficult to really read through. So it's nice to use actual names of the items instead of saying 3 items. So let's look at the actual name. To do that, we will change this. Instead of writing minimum support, we'll rather write what? Use the column names. Use the column names and set it up to true. So this time it's not going to give you that number 3. Okay, number 3 is the one. It's going to actually tell you the actual item name. So run this command. And when you do that, it will tell you that it is eggs. It's eggs that has a support of 0.8. Okay. Eggs has a support value of 0.8. Remember the definition of support? The number of items, okay, then divided by the total. So support for eggs is 0.8. What does that mean? What does that mean to say the support for eggs is 0.8? It means that eggs did what? How many percent of the time? That's what it means. What does that mean? And we are going to compare it with, okay, so when you have it there, it says that eggs appear 80% of all transactions in the data set. So when you take, there are 5 transactions, okay? Of all the 5 transactions, eggs alone appeared 80% of the time. Not that eggs appear in combination with other items, no. Eggs on its own appeared 80% of the time. That is what the support value is telling you. So please, when you look at that, does that tell you that egg is important or egg is not important? What does that tell you? Does that tell you that egg is important or not? So based on this, which particular item is the most important in terms of its frequency? Which item? Angela.
Kidney beans.
It is kidney beans. Okay. Out of all the 5 transactions, it appeared in all. It appeared in all. Now, what does that 0.6 here mean? What does that 0.6 tell you? I mean, I've given you the other one, so you should be able to guess. Valentina.
So it means that onion, kidney beans, and eggs appeared 60% in all the transactions together.
I like that last word. That is more important. Together. Okay, because on their own they appeared, but together. So when you go to every transaction, 60% out of the 5, these 3 appeared together. Okay. They may not have appeared in one, may not have appeared in the other, but then that is what it means. Okay. And then you can see that here, 80, I mean, if you look at kidney beans and eggs, it tells you how important it is. Okay. All right. Now, so when you have these things, you can now use the item sets to detect which ones you want to prune or which ones you want to prune. Now, this a priori will stop when no new frequent items can be formed, given the minimum support you've just set up. Okay. Remember, if we had not used minimum support of 0.6, and let's say we had used minimum support of 0.4, okay, just let's run that and see. You see now it's giving us a lot of items, a lot of possibilities, a lot, because we have just said that we want the minimum support. So anything that is, appears twice, okay, so up to twice or more, okay, so the minimum support value, those with a minimum support value of 0.6. So 0.6 is the minimum for the first one. But now 0.4 is the minimum. So anything 0.4 and above is going to show up. Okay, 0.4, 0.5, 0.6, 0.7, 0.8, and all of that. They're going to be showing up in that regard. But of course, it's also going to reduce the frequency. It's going to increase the frequency in that regard. Okay. That is why it's also important not to set a very high minimum support. Let me just go back. Okay. Now, the next thing, we have used numbers to represent, but we now know the actual items for the numbers. And Pandas works in that way to help us in that regard. Okay. Pandas makes it easy for you to focus on patterns that you are interested in. Specific items. Maybe you want minimum support to be 0.8 or 0.6 or 0.8. You can use Pandas to really let it generate for you. But we're going to do something that is beautiful here. We can look at the frequent item set, given this current minimum support, and then we can tell this guy, Jupyter Notebook or Python, that I want you to find all frequent items with a support more than 60% or more. But in addition, I also want you to do this and that and that. I also want you to find how many items are in each of the set. Okay. So whilst you are using the 60% kind of minimum benchmark, how many are in each sector? So let's go to run this. When you run this, what it does is that if the thing appears once, it will tell you. And it will tell you the support for that. So in short, what we are doing is that it's the same thing as the previous one. We are just adding how many times the thing has appeared. Now, this data set is small. So obviously, you could even check that, oh, this one has got what, 2 items. This one has got 1 item. This one has got 3 items. Yes, you can. But when you have a very large data set, you can't count them, because when some of them are 25, you're going to count the thing, and some of them have long sentences and all of that. So it's quite difficult to know that how many items are here. You can't count with your eyes. And so that is why we need this one to give us the length of the count. So we can, based on this, select the results that satisfied our desired criteria. And how do you do that? We can now say that I want you to tell me, this is a very interesting question. Okay, I want you to tell me the frequent items that are exactly 2. That's why you have a double equal to. That are exactly 2. So you just want this one. Now I can look at it with my eye. If there are plenty, I can look at this too. Okay, which are exactly 2, but not just exactly 2, but also in addition to that, they have an item support of 80% or more. So first of all, to be exactly 2, that's the one I've just highlighted. But which one of them have got an item support 80% or more? It's only the number 5 one item. Okay. Number 5. And that is what? That is kidney beans and eggs. So kidney beans together with eggs, okay, that is the only one that satisfies this condition. You can specify anything you wanted to find, for you, and it will pull out that, and you can speak around that. Okay, if you want 3, okay, those that are equally to, you just watch 3. Nothing will show. Suppose I go here and I say I want those that have 3 and are also 80%. Okay, you see, nothing shows. Nothing. Why? Because the only one that has 3, the support for it is 60% and not 80%. But the moment I change this one to 60%, it will give me that last, item set. So you can specify any one that you want, and then you get it. This was the original one that we had. I hope you get it. You can also specify that I want this item set that only contain onion and eggs. That's it. Okay, without giving these modalities, I just want those that contain only onion and eggs. And when you run that, it will give you this one, and it, of course, will have its support for you. And you can specify whichever items you want, you label the item. For example, if I want only onions, not onion and egg, I want only onions, I can delete this and just give me the one that is only onion, only one of them. Okay. But suppose I want only eggs, okay? Those that have only eggs, will just give me that one. Suppose I want onion and eggs, or onion and beans. Let me just change it. Onion and beans, and I run it. I get nothing because there's nothing, no combination like that. So these are some of the things you can request, and then you can get. Okay. So what is the use of all this in this first step? Practically, what does all this mean? Well, if you have a supermarket or you own a retail shop or a corner shop, a provision shop, you can place eggs and kidney beans together. Why? Go back here. Okay. Eggs appear 80% of the time, kidney beans appear 100% of the time. You can place these 2 together. Okay. Why? Because their support is very, very high. In other words, people generally buy these items together. So when you are shelving them, you will shelve these 2 items together so that the person will tap it here and take it easily. That's one practical application of this. So here, place the eggs and kidney beans close to each other or create a combo offer. In fact, you can create a combo offer. You can say that anybody who buys eggs will get a discount on kidney beans because you know that they already like it. And then you can create a discount for that. I'm telling you, that is what advertisers normally use for. The reason why you don't get an advertisement on electricity is because the number of electricity providers in Ghana are not many. And because there are not many, who's going to do an advert on electricity, that I'll give you a discount? No. But if you go to developed countries, it's always, everybody say, come and use my electricity. Another one I've already mentioned, you can use this for recommendation system, which we do a lot with Netflix, with Amazon Prime, Amazon Movies, Amazon Purchases, Jumia, and things like that. You buy one electronic, others are, okay. So now you go to the shop. If a customer adds egg to the cart, okay, the recommendation system says that the customers who bought eggs will also buy kidney beans. And you can use that recommendation system to ensure, again, that the two are shelved together, to ensure that anytime you are buying eggs from the wholesale, you're also going to make sure that you buy kidney beans of equal proportion, sometimes because they move together. How about this thing helping you in inventory management? Inventory management. Okay, you've seen that there's high support items. So those items with high support, you can stock more of it because people want them. It's not that they move together with another one. No, the people simply want them. So when you go to kidney beans here, kidney beans has high support. So you will not even wait for kidney beans to finish. Okay. The pre-order, the pre-order point. Okay. At that point where you got to order again or order before the thing finishes, you will always make sure that you increase that pre-order point for people to buy. Your inventory management will be fantastic in this regard. These are some of the practicalities which, again, when you're writing your essays, you can bring them. And then it also states here that you don't want to wait for the thing to be out of stock. You can do that. So generally, what is Aprari doing? Aprari has transformed the transaction data into knowledge. How has it done that? It's identified those items that are frequently happening and has converted them into actionable business rules, like those 3 points above. So that is it for this data. Okay. And you can use the association rule mining. In fact, so some of the exam questions you might get here would be, when we get to the next one, you see the deeper one. Is you being given a data set like that and you being given results like this. Okay. See here, I gave you the result for the actual names, so it's easy. But you being given results with numbers like this, and then the length to you will not be given. You should calculate the length of that because these are 2 item sets, okay, but these are 3 item sets. So, and then questions will be asked you about the actual name. So even though you have the numbers here, the same question, how do you find this? What is that? How do you find this? What is that? And this and that and that and that. Or even the entire data set, because this data set is smaller. This is the only thing that will be given to you is this. And then you ask questions. Okay. You should calculate the support for, onion and this. You should calculate the support for this and that. You should calculate the support for this and that. And you should be able to calculate the support for each pairwise or 3-wise items. And then you can make some recommendations based on that. Let's look at the next one. The next one is quite detailed. Association rule mining example 2. Okay. I've already spoken about all this, so I'm jumping here. So here, what is the total number of transactions? You can tell us. What's the total number of transactions in the second one? Quickly, this one. Somebody's counting. Yes, Falake.
9.
9, correct. Okay. So you have 9 transactions here. And as we know, apiary works on a binary data, not text, as we see. So we got to do a one-hot encoding, okay, from the pandas using this transaction encoder. We're going to do that. It will convert the transaction data into a binary matrix. As we know, each transaction and each column matches an item. It will help us to be able to use the apiary better because apiary doesn't work on textual data. It calculates the support, the confidence, the lift, the leverage, the consistency, all of this thing we did last time. It will have all of that. Okay, so given that data set, we are going to now use the encoder, which is this one, and then we will now fit the data and finally generate our data set. What do you get? This is what you get. Remember, we have items that are quite not many different items in each item set or transaction set. As you can see, the items are quite few, but it is how they are moving together. Okay, so you have bread, you have coffee, you have cup, you have milk, you have sugar. When it is true, it's 1. When it is false, it's 0. And watch it carefully. Based on this alone, you should be able to even do a lot of things. But what percentage are we going to use to be able? We are still going to use the 60% because of the nature of this. Okay. And how many transactions do we have? How many, how do you call it? From all the possible items and all the combinations that you see there, okay, we are keeping only those that appear in at least 60% of all the transactions. In other words, items and item sets with at least 60% support is what we are going to keep. Everything else is going to be discarded in our data set. Okay. So the 60% will lead to 5.4 because it's 60% of the transactions, which is 9 transactions. And since we can't find 5.4, 0.4 is a fraction. Okay. That is why we say an item or an item set must appear at least 6 transactions. Okay. It's actually 5.4 transactions, but we don't have points. So we say 6 transactions. So we're going to use that to be able to calculate. That 6 transactions will require that our minimum support is 2.9. And when you calculate the minimum support for 2.9, because we have 9 transactions, so the minimum support for that 9 transactions is going to be 2 out of 9. Okay. And because first of all, look at the items you have. We have only 4, 2 out of 9. That will lead to 22%. But we are still going to take the 2 over 9 to work out so that we don't need to force and run, what do you call it? Run down to 4 decimal places. So this 2.9 is going to be our minimum support. It means that an item or an item set must appear in at least 2 transactions to be considered frequent. Okay. 2 out of the 9 transactions to be considered. So if it is talking about coffee must appear in at least 2 transactions to be considered a frequent item. So what the question is asking you is find all the items and the item combination that appear in at least 2 out of the others. So we're going to calculate that. We're going to set the apiary of this data with that minimum support. And when you run this, it looks like I've not run something. Let me run my transactions. Oh. All of a sudden, something has happened. Okay, let me run the data. It looks like I didn't run the data. That's good. You always know. Okay, so we have our results here now. Let's run our apiary, and then we have this result. Now look at the item set here. Okay. Because of the minimum supports that we gave, we've got quite a number of support value, and then the item set. Once again, these items are in numbers, and we want to see them in the actual name. So And it's actually done it in that beautiful ordering. Okay, so apiary is going to return those indices. Very useful in downstream operations. And we've said it like association mining. But we want to be able to read it well. That's the sentence I've put here. So we want to convert these integer values to actual names. So I use this, and this time I just use the command called use column names. And then you get the actual names appearing instead of the numbers. So now you'll be able to know, if I were to ask you that based on this, which item is frequently occurring in this data set. Please remember, they have not been arranged in ascending or descending order. Which item is being bought a lot by most customers? Which item? Which singular item? Benjamin. Bread. Is bread. Okay. And bread is being bought most of the time with another product. Which product is that? Most of the time with another product. Which product is that? Be careful here. This is tricky. Bread is being bought most of the time with another product. Which product is that? Valentina.
Doc, we have bread and milk, and then we have bread and cup.
Just that.
Doc, please, we have bread and milk.
I know what you said. I'm not saying
Okay.
just that.
And bread and cup.
Where is bread and cup?
Bread and cup is the sixth.
Yeah, but you mentioned it.
I mentioned it, sir.
Yeah, so why are you mentioning that again?
Oh, sorry. I thought you didn't hear me.
I did.
Okay, thank
So
you.
how many are there? Set, the item set. How many items set are there? Angela. Joe Brighter. You people have names. So it's two, right? It's two. It's two. Basically, it's two. All right. So let's interpret the first row here. Okay, which has what? Only bread. This is interpretation. Bread appears 7 out of the 9 transactions. Okay, giving it a support of 77.78%. And that is not surprising because, as you can see, when you go up there, in fact, when you count bread, you see that it's appearing in most of the things. So bread is the most dominant item in our data set. It is bought by almost every customer. And that makes bread a core product. But look at the last one. The last one here. Bread is there, sugar is there, milk is there. What does that mean? It means that bread, milk, and sugar were bought together in exactly 2 out of the 9 transactions. So in all of the 2 out of the 9 transactions, giving this particular item set a support value of 22%, is the largest item set that just meets the minimum support. So your ability to interpret these things are critical. What it means is that because bread is super, anytime something else is being bought, bread is part. But what is the next super thing that is being added? And what is the highest of the super guys that can be put together? That is what that last one is indicating. Okay, we've already explained this point. Now let's go to, suppose I don't want this, I want portions. You want to create frequent item set, add new columns, take out new columns, store some of the data and all of that. What can you do? So this next command, okay, we can be able to use it to establish some few things. For example, you can use this command now to let it add the length to it, just as we did with the previous one. So this one is self-explanatory. Okay, so now we added the length. Here, we can count it with our eyes, but when the data set is big, you can't count it with your eyes. So we add the length to everything here. Okay. Now, and what I've just indicated here is that this is simply filtering the a priori result. Filtering it to tell you how many items are in an item set. That's all. Now, this is an interesting one. You can indicate that I want you to generate the length for me for those that are just 2 items in an item set. When you look up here, you see those that are just 2 items in an item. There are quite many, but it didn't bring it all. Why? Because we've added that their support must be bigger than 40% or must be equal to 40%. So it's going to look, its end, that end is important, it's together. So which of them have got that? If you check number 10, okay, the support is not 40% or more. If you check number 5, the support is not 40% or more. If you check number 8, support is not 40% or more. So we are talking about just 6 and 7 and 9. These are the ones whose support are 40% among those with a length of 2. Okay, and that is what this command will indicate. So now we can find the support for these items, and you can see that, just so you know, for those who don't have, just put it here. Okay, support is a proportion of the transaction. The length is the number of items. Okay, and you can see that the first part of this formula, I've just written it, the first part of the formula only keeps items that are exactly 2. So here, bread and milk are kept, but milk, bread, and cup are not added in that. And then you include the other aspect of it. Okay. You can also tell it that from all the frequent item set, I want you to show me only the row corresponding to the item set made up of bread and milk. Just give me that one. Okay. Why do we do that? Because sometimes the data is many. We have 35 million items, and you want to inspect one specific one. Okay, that is closer to your house, and you want to just check that combination. You want to know its support. You want to know its length. You want to even later calculate its confidence and its lift. And therefore, you want to just look at the current support value. We've not given a command for the others, but we can get a command that will give you everything. And the command is known as association rules. This command, guys, is a beautiful command. It will give you, of course, you got to specify the frequent item set. You got to indicate which metric you are dealing with, and then the minimum threshold. So look at this first command. The frequent item set is like an input, what you put there. Okay. And a priori will give you the result alone for that and tell you which items appear together for that particular one. But we don't have a rule for it, so we are going to add the next command. The rule is to choose a metric of what? Confidence. Okay. Now, if you look at this word association rule, the entire association rule command will take the frequent items, and I'm just reading here. Take the frequent items and will generate association rule for the 2 items that you are dealing with, any of the items. And then there is a command called the metric confidence. It tells you use confidence as the rule quality measure. So in other words, if you want to use a particular quality measure, use the confidence. Use the confidence, not the lift, not the this number. But then once you have the confidence, you can calculate the lift. Okay. You can calculate so many things. And that is why when you choose confidence, it's better. So the final one, when you put all of them together, you say that you indicated 70% minimum threshold. So that will set a minimum confidence requirement. So when you have 70% confidence, what it means is that the rule with the confidence below this 70% are not needed. You only deal with those that are 70% or more. They are the ones you are interested in. So who chooses that 70% and all those particular numbers? Books and documents and journals have consistently used simulations to come out with these numbers. So we shouldn't have a problem. But when you have a table like this, like what I'm going to give you, which captures everything you've done, You should be able to interpret so many things, guys. So many things. Number one. First, let's understand each column, okay? Because this is important. What do we mean by antecedents? The antecedent is that particular item that you are going to look at. The consequent is the item you're going to look at in comparison with the one used. So I've given you some interpretations here. That antecedents means items already in the basket. In other words, it's an item that you are saying that if a customer buys coffee, I'm just using the first one. If a customer buys coffee, that is a conditional one. Then the consequence is what will the customer buy next after coffee? So the consequence means that the item likely to be bought given the antecedent. So the fact that you have the bread at the top here means that then the customer will buy bread. Okay, so we now know the two, but what does the antecedent support and the consequent support mean? The antecedent support, as you can see, is 0.2, 0.2, 0.2, 0.2, 0.2 in all of them. It is telling you items likely to be bought given their antecedent. Okay, so the antecedent support is just telling you the support value, that percentage of the transactions containing that antecedent. So that particular transaction, how many percent is being eaten by that particular coffee here? And then the bread too, that particular bread, how many percent is being eaten or is being consumed by the bread? That is antecedent support and that of the consequent support. But now we come to the real deal, the support itself. But the support itself in this case is also 0.2, 0.2, 0.2. What is that? Well, the support for any particular variable is telling you the percentage of the transactions containing both of them. Okay. And in this, our example, because both of them were 0.2, 0.2, their support also becomes 0.2. Okay. So it's not, it's just X union Y. So obviously it's going to be that same union. And then the confidence. From the support here, you can see the next one is confident. All the confidences are one. That means you should be confident about, because remember the definition of confidence is a probability of buying coffee giving bread. What is a probability? If you can remember, it's probability of buying. It tells you the reliability, the trust, the confidence, more or less, that you will have. Okay, so if they are all 1, 1, 1, 1, 1, it tells you that we need to have confidence in those combinations. What about left? Look at the left. They are not exactly the same for all of them. Okay, so what does a left mean? If you can remember, the left tells you the rule against a random chance. And last time we indicated that even though confidence is more about a probability and hence potential causality, but leverage is about probability and potential causality. Left is about association, it's about correlation. So if you have a left greater than 1, it means there is a positive association between coffee and bread. But if it is less than 1, there's a negative association between coffee and bread. So a high left means that the value, the combination is occurring more frequently than would be expected given the number of transactions and the product combinations. Then there is another column for representativity. It's also 1, 1, 1. It simply means that it tells you how representative the rule is across data set. Okay, so if you have 1, it simply means that the data is very, very representative. Okay, so there's no bias in there. And then you have leverage. Okay, leverage is different from some of the values. What does that mean? Leverage is the absolute difference between the observed and the expected co-occurrence. In other words, leverage is telling you the practicality, because the word co-occurrence is talking about the association or the correlation, the absolute difference between the two. If it is, of course, going to be higher, then the co-occurrence is more. Otherwise, the co-occurrence is low. That is the leverage. And then finally, I'm not interested in the other ones, but finally, convection. The formula for convection is 1 minus the probability of a particular variable divided by 1 minus the confidence. So to be able to be convinced, you need to be confident. That's the whole point. It tells you the rule implication strength. And normally, if you get a value of infinity, which sometimes you get for most of them, infinity means that we have perfect confidence. For you to have infinity, confidence must be 1. I mean, you can check it here. If this one is 1, then you are going to have 1 minus 1, giving 0. Okay, any number divided by 0. Okay. So clearly, that's infinity. So when you go and check this, you see that conviction, all of them are infinity. And then we have some 4 other items which are not too important, but you should know them. I've put them there for you to look at. So let's go back to coffee and bread. If you were to write notes on coffee and bread, what would be your overall story? Practical. You say that coffee appears in 2 out of the 9 transactions, bread appears in 7 out of the 9 transactions. Every transaction that has coffee also will have bread. And that is why confidence is 100%. The left is 1.2857, which tells you that customers who buy coffee are 28.6% more likely to also buy bread than a random customer who just entered the shop. Okay, so this doesn't happen by accident. It is real. So in short, if you are to summarize the implication of the number for confidence and bread, you will say that whenever coffee is bought, bread is always bought together with it. And this happens significantly more often than chance will suggest. It didn't just happen by chance. It happened with a purpose. But when you want to interpret the last one, look at it. Sugar matching bread and milk. Sugar matching bread and milk. Okay. Sugar appears in 2 transactions. Sugar appears in 2 different transactions. In both transactions, you see that customers bought bread and milk together. When sugar was there, sugar's confidence is 1. And look at the lift. The lift is 2.25. It's more than that of the lift for coffee and bread. So it tells you that customers who buy sugar are 100, not just this one, which was 28%. Customers who buy sugar are 125% more likely to buy bread and buy milk together than the average customer would do. Very strong association. And there's a lot of business insight here. The business insight is that sugar is a bundle indicator. That's what it means. Sugar, you need it. It's bundled together. It's not just being used on its own. It's being used with several other things, cake and so many things. So whenever you are doing a promotion, you should include sugar. Whenever you want to give some offers, you should include it. Sometimes you can do some buy one, get one free, and people don't even want to buy it because the thing itself is not good. Okay. So in short, whenever sugar is bought, the customer will always buy bread and milk. And this happens more often than expected by chance. So that will be the interpretation you can get. In fact, for most association rule mining, this is it. This is what they are doing. It is a very, very specialized area of research where you can do some of these things. Now, sometimes you might do some graphical approach, but the graphical approach is good, all right, but it doesn't tell you much of the numerical instances that we have seen here. That is association rule mining. Ladies and gentlemen, that brings us to the end of the entire carboodle.